Hello, dear friends. Today I am here in this live streaming to take up another important topic in chapter 2 of class 10th. Now, this topic is related to the sum and product of zeros of a quadratic polynomial. A very important topic for class 10th students, and I hope through this live streaming, many of my students of class 10th will be greatly benefited. And if they solve some problems related to this concept along with me, then I don't think they will be requiring to do it all over again, because in itself this lecture will be complete. So, as my students start joining in, let me just take up the basics of a quadratic polynomial. The general quadratic polynomial is represented by ax square plus bx plus c. Now, this is a quadratic polynomial, and a quadratic polynomial has a degree 2. And I told you in my previous live streamings that number of zeros of a quadratic polynomial is 2. In all polynomials, you can find the number of zeros just by looking at the polynomial. So just identify the highest power, that is the degree of the polynomial, and you will come to know how many zeros does that polynomial have. Now in this case, the degree is 2. So we have 2 zeros of this polynomial. Now there are a wide variety of problems associated with this important concept of sum and product of zeros of a quadratic polynomial and the relationship between zeros and the coefficients. And we cannot escape these problems if you do this chapter of quadratic equations thoroughly for class 10th board exams. So as I welcome Hardik, Abhi, Aryan, Pradeep, Yuvraj, Anmol, Shivanshu, Vidhi, Surendra. Welcome all of you to this live streaming. Jot Kaur. This is Amanjot. Okay. Neha Sharma. She has been associated with the channel for quite long now. Neha. Okay. Let us get on with the concept first. Now see, whenever you have a quadratic polynomial ax square plus bx plus c, then it has 2 zeros, and now we have already done one video in which we learned how we can find the zeros of a quadratic polynomial. So we have already done that in the previous live streaming. Now we are doing the reverse of that video. This time the sum and product of the zeros will be known, and we have to find the quadratic polynomial. So it is reverse of what we were doing earlier. Or we will be given the zeros and we have to find the quadratic polynomial whose zeros are given. So I'll take a very simple example to tell you the concept behind this. Suppose the sum of zeros, that is 2 zeros are there for a quadratic polynomial, and the sum of zeros is given. So the sum of zeros which I am taking is a simple number, say 6, and the product of zeros is given as 8. Now whenever the sum and the product of zeros is known, then we can find out the quadratic polynomial of which the sum of zeros is 6 and product of zeros is 8. So I have taken a very simple value just to tell you the concept. As I welcome Mandeep Kaur, this is Kamal, okay? Hamsini, Manoj Kumar, Vanchita, yeah. So I'm glad to see you all eager to learn this important concept. So if the sum of zeros is given as 6 and the product of zeros is given as 8, then we can find the quadratic polynomial. Now this is the method. We have to first find the quadratic equation. See, required quadratic equation is x square minus. Now this is the formula which I am writing. So we will be using this formula in all the questions which we are doing today. X square minus sum of zeros into x plus product of zeros equal to 0. Now this is the important formula which we will be using today. So x square minus sum of zeros multiplied by x plus product of zeros equal to 0. Just notice carefully that after x square there is a negative sign, and after the term containing x there is a positive sign. So don't mix it up. Positive, negative, positive. Alternatively, we have positive, negative, and positive sign in the formula. Now, if we just substitute the values of sum of zeros and product of zeros here, we are going to get a quadratic equation whose sum and product is 6 and 8 respectively. So just substitute this here, x square minus sum. Now sum is 6, so just put 6, x plus product. Product is 8 equal to 0. Now this is the quadratic equation. Mind you, this is quadratic equation because I have put equal to 0 here. But if you remove this 0, therefore, required quadratic polynomial will be, just remove equal to 0. We have x square minus 6x plus 8. Now this is your answer. Very, very simple question. Obviously, this is the concept, so that is why I have taken a very simple example of 6 and 8. Now we will be making the problem more complex so that we can work out a variety of problems based on this concept. If there is any problem in this basic procedure, you can ask. Sachin, Biji, Manreet, yeah. Any problem if you have in this concept, you can ask. Otherwise, we can move on. I have put the important concept in the rectangle here. So just see that you have learned the concept. So these formulas work in all types of solving quadratic polynomials. Hardik, this is the concept for finding the quadratic polynomial whose sum and product of zeros is given. So you don't need to find the zeros. Just put the sum of zeros and product of zeros in this formula. You will get the quadratic equation. And if you remove the zero, this will become a quadratic polynomial. Abhi, I don't understand what are zeros you are telling. I just wish you would have seen the previous live streamings. If you have not seen it, kindly see the last two live streamings because this is the follow up of that video. Okay, so most of the students are ready for the next concept. Now, if you have understood this, now we can take one or two more examples. Then we will get on to some complex problems. Now, this time, suppose in question 2, the sum of zeros is given as minus 1 by 2 and product is given as 3 by 4. So minus 1 by 2 and 3 by 4. Now if you put the values of sum and product in that formula, let us see what we get. We have some doubts here. Okay. What is the shortcut to get value of roots? Bhavya, I've already put how to solve a quadratic equation mentally. Just see the channel. Vidhi, sir, this formula for all these types of questions. Yeah, there are a wide variety of questions based on this concept, Vidhi. So be patient. We will have all the concepts done. Okay, Hamsini is already answering x square plus 0.5x. Don't need to have decimals in the quadratic polynomial, please. So just see how we avoid these decimals. Vanchita, again, you are having those fractions in that polynomial. We have to avoid those fractions, and this is what we have to learn. Kindly see this. Now see, x square minus sum x plus product equal to 0. I am denoting sum of the zeros as s and product of the zeros as p. Now I will substitute the values. X square minus sum is minus half, x plus product is 3 by 4 equal to 0. So x square plus x upon 2 plus 3 upon 4 equal to 0. Now this is a quadratic equation having 2 and 4 in the denominators. So what is the LCM of 2 and 4? It is 4. So now what we do is we multiply throughout by the LCM. So multiply throughout by 4. Because 2 and 4, the LCM is 4. So what we do is we multiply the equation throughout by 4. Now remember, this is an equation we can multiply throughout. But in case of polynomial, we cannot multiply or divide the polynomial. Okay. So in this is that is why we wrote in the beginning the formula as a equation. So now multiply by 4, x square becomes 4x square. If you multiply x upon 2 by 4, you get 2x. And if you multiply this by 4, this 4 is removed. Now see, there are no fractions, there are no decimals in this. So this is what you have to achieve. The values, the coefficients should be perfect integers. So I think most of you have understood this. Yeah. So now you can remove the zeros. 0 equal to 0. So this will become x square, 4x square plus 2x plus 3. Now this is the required polynomial. Now in the exam, when you have found out the polynomial, just try and factorize this using the method of splitting the middle term or whatever methods you will learn in quadratic equation chapter subsequently, so that you are assured that sum and zeros are the same. And if you know the relationship between zeros and the coefficients of the polynomial, we have done it in the earlier video. Sum of zeros should be equal to minus b upon a. So minus b upon a, minus 2 upon 4, minus 1 by 2c, minus 1 by 2, and product of zeros c upon a. So c upon a. So 3 upon 4. So 3 upon 4. So this is a simple verification which you can do if you know the relationship between zeros and the coefficients of the quadratic polynomial. I hope this question is clear. I'll give you one question for solving now. If this is clear, we will get on with some complex examples now. Anmol, if you want me to repeat, you can see it again here. Sum of zeros is given and product of zeros is also given. Now we need to find a quadratic polynomial whose sum of zeros is this and product of zeros is this. So what we have done is we have first written the concept x square minus sx plus p equal to 0. This is the way how we find a quadratic equation whose zeros has the sum this and product this. So just put the values of s and p given here in the equation, you get a quadratic equation. If that contains fractions, then take the LCM of those fractions and multiply throughout by that LCM. So you will have those fractions removed, and once those fractions are removed, then you can remove this is equal to 0 to get the required polynomial. So I have repeated the entire process. If you are ready for the question, then we can get on with it now. Okay, as I welcome Monica Agarwal to the channel. Monica, 7:30 is the live streaming time, so you're again 15 minutes late. I hope you follow what we are doing right now. Okay, now let us have one question. Now the sum of zeros and product of zeros I am changing, and you will start your answer from this step. Now the sum of zeros is given as 7 upon 8, and the product of zeros is given as 5 upon 12. Now let me know what is the quadratic polynomial. Sum of zeros is 7 by 8 and product of zeros is 5 by 12. This is for you viewers. Substitute the values of s and t here. Remember, no decimals, no fractions in the answer. No decimals and no fractions in the answer. So I'm waiting for the first correct answer. In the meanwhile, I'll also try and solve this. See the steps on the board only when you fail to complete it yourself. Remember to take LCM of the denominators and multiply by that number throughout. It's a very simple question. I hope you have got your answer by now. If you have got the answer, you can tally it from here. I'm already having some answers. Okay, and more you got to check it again because I think X is missing from your answer, and moreover, the answer seems to be wrong there. Yeah, I'm getting some right answers now. Raja Ratna, yeah, 24x square plus. Just check the sign there, Raja. Vidhi, 24x square minus 21x plus 10. Yeah, that's great. You've got that right. Hardik, yes, that's what matters in mathematics. You have to be accurate with your answers. Surendra, 24x square, x square. I think you have not written x in the first and the second term. Okay, so I've done it on the board. You can verify your answer and the steps which I have followed to get that answer. 24x square minus 21x plus 10. Bhavya, very good. Okay, now let us have two more steps added to this question. Varsha, normally I get live at 7:30 p.m. You can see the events on the channel and you will come to know. If you have subscribed, you will get the notification also as soon as I am live. Mandeep, well done. 24x square minus 21x plus 10. Very good. Okay, now we will have one more question in which the zeros are given. Here the sum and product of zeros was given. Now two more steps will be added to the question. Now see, this is question number 4. Find a quadratic polynomial. Find a quadratic polynomial whose zeros are now we are given the zeros -3 and 7. Remember, these are not the sum and product, these are the zeros. Now the values of the zeros are given to you. So one more step, rather two more steps are added to what you were doing just now. Now in the solution, what you need to do is just take the first 0, let alpha is equal to -3 be the first 0. So the two zeros are given. So I am assuming that the first 0 is alpha and beta equal to 7 be the second 0. So I will assume the two zeros to be alpha and beta. So once you have alpha and beta, the two zeros, you know that the quadratic polynomial contains sum and product. So you have to find sum of zeros, that is alpha plus beta. So add the two zeros, -3 plus 7, this is 4. And product of zeros, alpha into beta, that is -3 into 7, that is -21. So students, see, whenever zeros are given, assume the two zeros as alpha and beta, and then find the sum and product of those two zeros, alpha plus beta and alpha beta, by adding or and by multiplying them. So now the question is same as the previous concept which we were doing. So once you know the sum and product, you can substitute the values in this required quadratic equation is x square minus sum x. Okay, now in place of sum I have alpha plus beta, so I'll write it here, x square minus alpha plus beta into x plus alpha beta equal to 0. Remember the concept, sum is in the middle term and product is in the constant term. So x square minus sum x plus product equal to 0. So just substitute the values now. That implies x square minus sum. What is sum? 4x plus product. Product is -21 equal to 0. So the required quadratic equation is this. This is the equation, and just remove 0 because it does not contain any fractions or decimals. So therefore x square minus 4x minus 21. This is the required quadratic polynomial. So whenever the zeros are given, assume them as alpha and beta, and then find the sum alpha plus beta, product alpha beta, put it in the formula which I have been telling you in all the 4 questions, and then obtain the quadratic equation. From that, remove 0 to get the quadratic polynomial. So any doubts here? Yeah, students, any doubts here? I'm glad I'm getting the right answers. Many of you have already given x square minus 4x minus 21. Yeah, Mandeep got it right. Raja, very good. Vidhi, always you are right. So keep up the good work. That's great. Many of you are just watching but not replying. So I expect more replies from the viewers. So many of you are following but not giving answers. I think due to the fear of giving a wrong answer. Don't worry. Here we have gathered just to learn. Surendra, yeah, x square minus 4x minus 21. That's correct. Okay. 4x is not taken in the place of minus 4, Varsha. But why 4x is not taken in the place of minus 4x? I didn't understand. I didn't get you. Actually, the formula contains a negative sign here. So if alpha plus beta is positive, obviously this will be negative only, minus 4x. If alpha plus beta would have been negative, then the center term would have been positive because there is a minus sign in the formula also. Okay, one question for you now. Find a quadratic polynomial whose zeros are. Now I am changing the zeros, and the same steps you have to follow to get the required answer. 3 by 2 and minus 5 by 4. Okay, now I have changed the values. You have to find a quadratic polynomial whose zeros are 3 by 2 and minus 5 by 4. Students, kindly get on with this and follow the same steps which I just told you. Find the sum of zeros, then the product of zeros, then put the sum and product in the formula which I told you. So I'll just do a little bit of work for you. Let alpha equal to 3 by 2 be the first zero and beta equal to minus 5 by 4 be the second zero. So alpha and beta are the two zeros. Now find the sum and product. So if you find the sum of zeros, this is alpha plus beta. So alpha is 3 by 2 and beta is minus 5 by 4. So obviously 4 is the LCM. So 6 minus 5. So your value of sum is 1 by 4. Kindly keep on checking. I'm already having some answers. That's great. The speed of calculation is really increasing now. But Varsha, I think you were not there when I told you that the final answer should not contain decimals and fractions. So if you have fractions, then take LCM and multiply throughout by that number. Same problem with the answer given by Durga Priya. So kindly remove that fraction from there. Yes. So people who were following from the beginning, Bhavya, Hamsini, Hardik, Raja, they have all given the answer in simple terms. Okay, I have yet another answer by Surendra. Okay, now let me just check whether you got that right or not. So sum is 1 by 4 and product alpha beta is 3 by 2 into minus 5 by 4. So this is minus 15 by 8. So now put the values in x square minus sum x plus product equal to 0. So x square minus sum is 1 by 4. So x by 4 and plus product is negative. So minus 15 by 8 equal to 0. Multiply throughout by 8, you get 8x square minus 2x minus 15 equal to 0. So if you remove the equal to sign, see, mind you, equal to sign can only be removed when you have removed the decimals or the fractions. So your answer is 8x square minus 2x minus 15. I think most of you got that right and really commendable. Everyone getting the right answer there. Sachin, Anmol, Vidhi. So everyone is getting that right. So I hope the concept is clear. One more question, then we will get on to one more type of question based on this concept. Now change the roots here, the roots or the zeros. I am changing the values of the roots now. Let us see what answer do you get now, and this time I'll see who is the first one to give me the right answer. This is minus 1 by 5 and 7 by 10. Now find a quadratic polynomial whose zeros are minus 1 by 5 and 7 by 10. Now let me see the first right answer which I get. Waiting for you to solve it. No hints this time. Okay, Rajinder, I think you are answering the previous one. We have one more question on the board here. This is minus 1 by 5 and 7 by 10. Still waiting for the right answer. I'm just solving it on the board. In the meanwhile, I already have some answers. So let me just tally. So many answers I've already got and I've solved it on the board. Let me just check who got that right first. 50x square minus 25x minus 7. Okay, Shoaib, I think you were just following silently and you got that right. Very well done. Followed by Bhavya, Hamsini, Vanchita. Yeah, most of you have given the right answer. Surendra, kindly check that 45. Hardik, well done. Sachin, you got that right. Your message. Okay. Who else? Pradeep, 50x square minus 25x minus 7. Good. Vidhi, Mandeep, Varsha, there should be a x with that 25 which you have written in the middle. 50x square minus 25x. Surendra, 45 is not right actually. Yeah, okay, that is 50. That's great. Yeah, so many right answers. I'm so glad all of you have followed this very important concept. Now, based on this relationship between zeros and the coefficients, I'll just tell you the relationship between zeros and the coefficients so that you don't have any problem with the concept. See, whenever we have a quadratic polynomial ax square plus bx plus c, obviously there are two zeros, and if I represent the zeros by alpha and beta, then the sum of zeros, that is alpha plus beta, is given by minus b upon a. So this is the first concept. And the second, product of zeros is alpha beta. It is given by c upon a. Now this is the concept which we have been doing in the last two live streamings. And this important concept has been used here also. Sum of zeros and product of zeros we have already found out. And this concept you can use it to find your answer whether it is correct or not. So you can verify very well in the examination whether your answer is right or wrong. Yeah. So now another important thing. See, I need one more live streaming tomorrow for completing this topic because it is a very, very big topic and you find a wide variety of problems on this concept of sum and product of zeros, alpha plus beta and alpha beta. So I'll take one or two basic examples today and then we will continue the video and finish it tomorrow only. So this is the first question based on this concept. If alpha and beta are the zeros of, in some books you find in place of zeros it is written roots. So zeros, roots or solutions, these three are the same things. If alpha and beta are the zeros of, basically zeros is used, the word is used when there is a polynomial. Roots and solutions are used when there is a equation. So if alpha and beta are the zeros of, now you are given a particular quadratic equation. Now this is 3x square minus 4x plus 5. So if alpha and beta are the zeros of this polynomial, comma, find the value of, now this is the first part, alpha square beta plus alpha beta square. Now this is the first important problem of this type, and we will surely do lots and lots of problems of this kind because Very often you find this question in board exams. So if alpha and beta are the zeros of this, you have to find the value of this. Now the first thing which comes in mind is to find the zeros of this given polynomial and represent that by alpha and beta and put the values of alpha and beta here. But always you will not find a polynomial whose zeros can be found out very easily. Here middle term splitting will not work, and you need to make use of this concept of sum of zeros is minus b by a and product of zeros is c by a for solving this type of question. So never think of finding the zeros of the given polynomial. That will consume a lot of time and you may not be able to find the zeros as well, because every polynomial is not factorizable. The middle term cannot be split. So I'm getting some answers there. That's very good. I think we have done the concept earlier also. So now how to solve this? See, in this polynomial 3x square minus 4x plus 5, you have the value of a as 3, this is the coefficient of x square, the value of b as minus 4, this is the coefficient of x, and the constant term as c, this is the value 5. Now abc, the values are known. Now use the relationship. Now see, sum of zeros alpha plus beta. Alpha plus beta is minus b upon a. So I'm putting the values minus b. What is b? Minus 4 upon a. What is a? 3. So this is 4 upon 3. So we have got the value of alpha plus beta. And similarly, alpha beta. What is the formula for alpha beta? C upon a. C is 5, a is 3. So 5 upon 3. Now these are the two values you require to find in all such questions. Whatever polynomial is given, the coefficients are to be labeled as a, b and c, and then for use the concept which I have written here, alpha plus beta is minus b upon a and alpha beta is c upon a. So based on that concept, I have found the value of alpha plus beta and alpha beta. And now we can find out what is required. Now the required thing is we have to find the value of alpha square beta plus alpha beta square. So after this I am solving here. The value required is now alpha square beta plus alpha beta square. See, here we can take alpha beta common. So if you take alpha beta common, you are left with alpha plus beta. And this step solves our purpose. Why? Because the value of alpha plus beta is known and the value of alpha beta is also known. So whatever question is given, we have to reduce that question in the form of alpha plus beta and alpha beta. So if you are able to do that, then the value is very easy to find out. So just substitute the values of alpha plus beta and alpha beta. The value of alpha plus beta is 4 by 3. So substitute the value of alpha beta, it is 5 by 3. This is 5 by 3. And multiply by alpha plus beta, it is 4 by 3. 4 by 3. So just multiply the two, you get 20 by 9 as the right answer, which many of you have already given the answer. Bhavya, you gave that answer very, very quickly, followed by Raja and Hardik, Mandeep, Vanchita, yeah, Vidhi, yeah, everyone is responding now. So I think you have got that concept very, very easily. Now, in the same question, suppose you have a different thing to answer, different value to find out. Now, up to here, the question is okay. Now, suppose you make a second part of this question. You have to find the value of 1 over alpha plus 1 over beta. Can you do that, students? The value of 1 over alpha plus 1 over beta in the same question. I am waiting for your replies. The value of 1 over alpha plus 1 over beta. The value of 1 over alpha plus 1 over beta. Still waiting for the first answer. The same question, you have to find the value of 1 over alpha plus 1 over beta. Hamsini, yeah, Hamsini got 4 upon 5, I think. Raja, the same answer, 4 upon 5. Pradeep, 4 upon 5. It's not that tough. I think the answer should have been there by now. What is the problem? I fail to understand here, because you have to just take the LCM. Alpha and beta, the LCM is alpha beta, and in the numerator you will get beta plus alpha, that is alpha plus beta. So now we have reduced it in the form of alpha plus beta and alpha beta. So just substitute the values and get the result. Alpha plus beta is 4 by 3. This is 4 by 3. And alpha beta is 5 by 3. 5 by 3. So that upon 3 gets cancelled and 4 by 5 is the required answer for the second part. So students, I hope you have understood this concept, because tomorrow's live streaming is based on this concept. So whatever we are going to do tomorrow, if you have not understood this, you can ask me now itself, because otherwise you are going to face a problem tomorrow. Yeah, see, now I'm getting a lot of answers. Sachin, Vidhi, Mandeep, Hardik, everyone is giving the same answer now. Vanchita, very good. I'm glad, Vanchita, today you are giving your answers. Do not fear if you get any wrong answer. This is the learning curve. Whatever mistakes we have to make before appearing in board exams. So, no mistakes allowed in board exams. Vidhi, I'm so glad, no doubts. So, the very purpose of giving this lecture has been solved. And I wish my entire school students, they all participate. Guess what experience that would be if we have 100 students participating and giving me the answers. That will be a very, very big event. Okay, so tomorrow we will have very complex problems of this concept. Do join in, because that will be really challenging, and it might take 1 hour live streaming for getting this topic done. So most of my students who have joined in, they have been regular, and I guarantee you that most of the topics, most means everything, will be covered on the channel by say 2 or 3 months of live streaming. So you will have lots of time for recapitulation, for doing your work. So I'll see you tomorrow with more number of questions, more complex questions on this important concept. Till then, God bless all. Thanks for watching. Bye bye.